Alright, let's get started with 7.2, multiplying and dividing radical expressions. Alright, here we go. So, we're going to learn how to multiply, and we're going to learn how to divide radical expressions. Pretty straightforward what's going on in this section. Only new vocab is rationalizing the denominator, and this is something that next year in pre-calc, lots and lots of my pre-calc students forget. So let's learn this pretty well first time around, so we don't have to learn it again next year. So, couple skills we'll need. Let's get started with this one. Let's check this out. 150 can be broken down into 5 squared times something. So let's see. 5 squared is 25. 150 equals 25 times something. Let's make that an x. We can divide both sides by 25, and we get a 6 for x. So we can put an x in here because we know that missing things in algebra are x's or y's or some kind of variable. And so your job here is to solve for x. So 1 is down. Let's see if you can do 2, 3, 4, 5, and 6. Pause the video. When you're ready to go, press play again. Alright, so multiplying radical expressions. So to multiply radicals, let's look at an example first. So here we go. 16, square root of 16, times the square root of 9. We all know that the square root of 16 is 4, the square root of 9 is 3, and if you times those, you get 12, right? So when we go root 16 times root 9, we should get 12. So let's see how we do that. If we take the 16 and times it by the 9, we get 144. Is the square root of 144 12? Absolutely it is. So that's the rule. The rule is you can multiply the radicands, right? That's what we call the numbers underneath the square root. Multiply the radicands and then square root the result, the product. All right? So when we work on cube roots like this, okay, when we do this, we start with the cube root of negative 8. That's negative 2. The cube root of 27, that's 3. And we should get negative 6. All right? Let's see if that works to just multiply them together. Negative 8 times 27 is 216. Is the cube root of that 6? It is. We've got a negative, so it matches up. So we've got ourselves a rule here. If the index is the same, n and n, we can multiply the radicands and then do the square root or cube root or fourth root, whatever the index is telling us to do. So let's try to do that with a couple options here. So examples here. Square root of 2 times square root of 8 is square root of 2 times 8, which is the square root of 16, which is 4. The cube root of negative 5 times the cube root of 25. Let's see what's going on here. We're going to multiply them together, and 5 times 25 is 125 with a negative in front. The cube root of that is negative 5. And let's do the last one here. This is going to be the square root of negative 16. And we can't do that because we can't square root and get a real. Remember, we've already talked about imaginaries, but no real solution for C. Your turn. See if you can do the understanding check for number 1. Okay, simplify each expression. Assume that all variables are positive. We're going to simplify here. All right, so we need to break this up. This is why we did the skills check. So let's remember what our pattern of squares are. So we've got our perfect squares. Remember our 4, 9, 16, 25, 36, and so on and so forth. I'm going to stop at 36 because I see that 72 is 36 times 2, and x cubed is x squared. I'm going to pull the biggest multiple of 2 out, times x. All right? So square root of 36 is 6. That comes out. Square root of x squared, that comes out to just be x. And we're left with 2x underneath the square root. Let's do b. Well, on this one, we need our perfect cubes. 2 cubed is 8, 3 cubed is 27, 4 cubed is 4 times 4 is 16, 64. And can we stop there? Yes, we can. Could have stopped after the first one, actually. let's see here. Cube root of 80 is the same as 8 times 10. There's our perfect cube. We're going to multiples of 3 out. N cubed and n squared. Cube root of 8 is 2. Cube root of n cubed is just n. And everything else needs to stay underneath the cubed root. 2n cube root of 10n squared. That's your answer. This was the answer to number A. Your turn. See if you can clean up understanding check 2. All right, so let's multiply and simplify these. So we're putting both things together here. So let's multiply first. 54 times 5 is going to be, let's see, 250, 270. X squared and x to the third is going to give me x to the fifth. Y cubed and y to the fourth is going to give me y to the seventh. And then we want the cube root of that. All right. 27 is a perfect cube. So I can say 27 times 100. And x cubed is the biggest multiple of 3. Y to the sixth, though, is the biggest multiple of 3 for the y's, and then 1y left over. So let's break this down and pull them out. 3 x y squared. 6 divided by 3 is 2. And then, last but not least, we've got what's left over. Cube root of 100 x squared y. Okay, so this y squared part is the new interesting part on this one. The cube root of y to the sixth. Remember that cube roots in exponents are the same as saying a third. So what's 6 divided by 3? That's where the 2 comes from. All right? So you're just going to divide when you do the square roots when you're dealing with exponents. So that's your final answer. All right? Your turn to do the exact same thing with different numbers on Understanding Check 3. All right, let's get to the second objective here, dividing. So when we divide, we're doing the exact same rule as multiplying. We can divide the radicands and then do the root of that. All right, so same rules apply here. So cube root of 32 over negative 4 is the cube root of negative 8, which is negative 2. The cube root of 162x to the fifth over the cube root of 3x squared is the cube root of, put them underneath, 3x squared in the denominator. 162 divided by 3 is going to be 50 plus 4. Let's see, so we've got cube root of 54, and then we subtract straight down x cubed here. So one extra step in this one, we need to see if we can find the perfect cube. 54 is 27 times 2, and x cubed is a multiple of 3. 27 gets to come out. X gets to come out. We're left with the cube root of 2. And that would be your simplified, divided answer. Try understanding checks A, B, and C. All right, so now we need to rationalize the denominator. Here's that new phrase. So the key here is that you are not allowed to have a square root in the denominator, all right, because denominators need to be rational numbers, okay? We need to have a decimal that stops. Square roots that don't simplify don't do that. So here's how we get rid of them. We're going to take whatever we've got, root 2 over root 3, and multiply the top and the bottom by whatever we had in the denominator. So now we've got root 6, square root of 3 times the square root of 3 is the same thing as square root of 3 squared. Square roots and squaring cancel, and we're just left with 3. That's our answer. We're going to do the same thing here, 5xy, top and bottom. We're going to get root 5. Add your x's together, 3 plus 1 more, x to the fourth, y, over 5xy. All right, we can clean this up a little bit because this x to the fourth is going to come out and be x squared on the outside, over 5xy. And then look at this, we're going to cancel some x's, so final step here would be x root 5y over 5y. Alright, so a lot of simplifying to do on that one. Alright, now the cube root, a little trickier here. This is the cube root of 2 over the cube root of 3x. Okay? So we want to cancel out cubes with perfect cubes underneath. So the way we'd have to get rid of this is multiply by the cube root of not just 3, but 3 squared. And not just x, but x squared. So that when we multiply together, let me put it on the top in the numerator. Let's see what we get when we multiply the denominator. 3 times 3 squared is 27. X squared times x is x cubed, and that's going to cancel out, and we'll end up with just 3x in the denominator. On the top, we ended up with 3 squared is 9 times 2 is 18. X squared. Alright, so cubes get a little messier, but just keep track of all your terms and you should be okay. See if you can do that for the next understanding check, number 5. Alright, real world connection, let's wrap it up with this. Einstein's famous formula, E equals mc squared. I'm sure you've heard of this. Relates energy, mass, and the speed of light, which is c. Express c in terms of E and m and rationalize the denominator. Here's the steps. We've got our equation. We want c by itself, so let's divide by m. We've got c squared equals e over m. How do we get rid of the squared? Square root it. So c equals the square root of e over m. We're not going to be allowed to keep that root m on the bottom, so we need to multiply top and bottom by m. Square root of m squared is just m. So that's our final simplified answer. Your job is to do something similar with this formula, area equals d over t squared. Sorry, not area, acceleration. Acceleration of a moving object relates to its distance and time with that formula. Get t by itself, move it to the top, square root, and then rationalize your denominator. Give that a shot, and we'll go over the answer in class. Any questions? We will talk about it then as well. Good luck.